Okay, so here's a problem. We've got a circular field and we've got a rotating sprinkler that's pinned at the center of the circle, and it's this length here. It's one radius. It's 10 meters long, and it's going to go around the whole circle eventually. And I'd like to know, as it goes from B to C, the other end that's going around the circle, how far is it going if the angle it's made is 60 degrees? So this is a very typical problem about circles and lengths, and we're talking about an arc of a circle. So B to C is called an arc of a circle, and we're interested in the length of that portion of the circle if we know the radius and we know this angle. So in general, we're going to want to know the length of any portion of a circle, and that's the technical term is an arc. Ooh, don't need all caps though. And it should have to do with how big the circle is, and almost always we're going to use the radius as our preferred measurement. Sometimes we're going to have to go back and forth between diameter and radius. And it should, of course, have to do with how much of the circle is involved. Like DE here is going to be less than BC, is going to be less than CD. More and more of the circle is going to be longer arcs. So a little bit of terminology. If I say the portion of the circle between B and C, and I don't clearly indicate that it's this small portion here, I could mean going around the back way, going clockwise from B all the way around to C. And I need to have a distinction there. So what's called the minor arc, and what we do is we take the two endpoints of that arc. I'm going to use a little hat symbol because this computer program doesn't do what you see in the book, which is a more curved, kind of a nice little circular arcy thing. So it's really a curved thing. It's not a sharp hat, but that's what this computer program will do. The minor arc BC, that's going to be less than a semicircle, less than halfway around. So if I just name 2 points on the circle and say arc BC, that's this minor arc. How would I then get the major arc, which is going to be, what if I did really mean start at B, go all the way around the other way, more than 180 degrees around to C? You could imagine there'd be some sort of little notation, go clockwise or go counterclockwise. It just turns out that what you do is you just label any point that's on the other, going around the other way, like D, for example, or E. I'll use E, okay? And if you use 3 letters, that's telling you kind of go out of your way, go the long way. So if you have B, this just says, okay, go towards E, and then go from E to C. And if that amounts to going around the long way, that's instructing you to go the long way, okay? And so that's going to be anything that's more than a semicircle. And of course, sometimes you have exactly the semicircle, in which case you really do need to tell me which way to go around no matter what, right? And so a semicircle would be, for example, that upper semicircle, if I want to talk about that, would be like BCD. That'd be the upper. Or BED, bed, okay? And that would be the lower. So some useful terminology, as always. Terminology is really important because you want to be able to talk precisely about these things, or else you're not going to get anywhere. But the main thing we're interested in is the length of that arc, and there's 2 ways to talk about how big that arc is. So now we're going to go back to BC, focus on that. And the arc measure, that terminology, really just is trying to get a sense of, independent of how big the circle is in terms of radius, distance, that kind of stuff, meters, centimeters, just how much of a circle am I, is this arc going to be? And a good way to measure that is just the angle it forms at the middle, okay? So the measure of an arc is just the angle measure of the corresponding central angle. So whenever I have a portion of a circle, if I want to, I can stand at the center, draw these 2 radii to the 2 points and measure the angle, and that's going to give me an idea of just how much of the circle are we talking about. Like this 30 degrees, that's a smaller portion of the circle, that's 60 degrees. You can figure out for yourself, I'll probably put it in as a question, what the angle measure here of CAD is going to be, and that would talk about the measure of the arc here. And so we just do that the same way as we would measure an angle, just put the little lowercase m. So the measure of arc BC is just that 60 degrees. Okay, so that's one of the key pieces of data, how much of the circle expressed in terms of the degree measure of that angle, or in other words, the measure of the arc. And then, of course, the really, really key thing is the circumference of the circle. That's just how far it is around the entire circle. And let's look at, and just one more piece of terminology. The actual arc length is the actual physical length of the arc. That's what I said, what I wanted to get at the start. That's what we're driving towards. Just if this is 10 meters and I start here and I walk along here, just how far am I going? If I put a tape measure from here to here, curving around on the circle, how far is that? Okay. So the first thing we want to know is we're going to figure out, well, we're going to have a theorem, a very famous formula that tells you just the entire circumference of the circle. And that is something that is a pretty deep thing. And this is where the famous number pi starts to come into things. The circumference of a circle is 2 pi times the radius. Something we absolutely want to memorize and have really, really down. Soon enough, we're going to also think about the area of a circle. That's going to have to do with pi as well. And you don't want to confuse the two. But the big theorem is that the circumference of a circle is 2 pi times the radius. So it's about 6.28 times the radius. So if this is 10, then the entire circumference is about 62.8. And that's really crucial. Now, once we have that, that's something we really just commit to memory. Now it's just proportions. It's pretty easy. Okay. How much of a circle? How much of the circle are we talking about? Okay. And that's pretty easy to do because we know all the way around the circle is 360 degrees. So we're talking about something that is 60 degrees out of the 360. And that proportion is in terms of angles, how much of the circle are we talking about? And that's going to be the length that we want, we'll call it L, over the 2 pi r, which in this case, let's actually put in the radius, that's going to be 20 pi. Okay, well, hey, 60 over 360, I made that so that wouldn't be too hard. Let's simplify that down. We don't need to get 3 or 4 digit numbers in here. That's just 1/6. We're talking 1/6 of the circle. Okay, and so easy to solve for L is just going to be 20 pi over 6. That simplifies down a little bit. That's 10 pi over 3. And if we want that numerically, which the farmer probably does, that's going to be just over. So it should look like that's plausible. If this is 10 and you took a 10-foot tape measure, 10 meters, whatever I said, it almost stretches here, almost reaches around. It's just a little bit short. It's actually about 10.5. So this is the story we're going to tell about arcs and their measures and their lengths. That we talk about how big an arc is on the circle irrespective of radius based on how much angle is the corresponding central angle. We're going to do very simple proportions with 360 degrees to get arc lengths.